Let's say there are two engineers who work for a construction company. They need to order cement bricks for a certain project. They have to build a wall that is 10 feet wide and plan to lay the base with 30 bricks. The first engineer does not consider the importance of significant figures and calculates that the bricks need to be 0.333 feet wide, but the second engineer does and reports the number as 0.3, since they figured that a precision of 0.01 feet or 0.1 inches would be precise enough for the work they were doing. Now, when the cement company received the orders from the first engineer, they had a great deal of trouble. Their machines were precise, but not so precise that they could consistently cut to 0.001 feet. However, after a good deal of trial and error and testing, they finally machined all the bricks that were needed. Now, when they used the second engineer's orders, which was 0.3 feet, it was much easier for the machines to create concrete blocks compared to the first engineer. It generated minimal waste and overall took a lot less effort. When the engineers received the bills, they compared the bill for the services, and the first engineer was shocked at how expensive his was. When they consulted with the company explained the situation. They needed such a high precision for the first order that they required significant extra labor to meet the specification. This is why it was much more expensive for the first order. So what is the point of this story? Significant figures matter. It's important to have a reasonable gauge of how precise a number is, so you know not only what the number is, but how much you can trust it and how limited it is. Significant figures tell us where to round, so we don't have to worry about rounding to specific decimal places. But the main point of significant figures is to make sure that the answer we calculate is not more precise than the numbers we started out with. And to explain on what I just said, here's an example. Let's say I wanted to find the mass of these two burgers. To find a more specific answer, I used the NASA laser scale, which came out to 15.53354 grams. To find a less specific answer, I used the toy scale, which came out to just 15 grams. So let's say I wanted to find the density of the burger. Somehow I found the volume to be 3.5 centimeters cubed, so when using the density equation it came out to this really specific number, which doesn't make sense because I started out with two imprecise numbers, and it came out to a really specific answer that I could have gotten using the NASA scale. Now this time I rounded my final answer using significant figures to 4.3 grams over centimeters cubed, which makes sense because my answer is just as precise as the numbers I started out with, and because out of the two initial numbers, the least amount of 6 figs is 2, which means I had to round it to 2 6 figs. Now on the other hand, if we started out with two really specific numbers, then it would be totally fine to have a really specific number. But that is only because we started out with two really specific numbers in the first place. Now I'll use an analogy to help explain this even further. Let's say you're with your friends and one of your friends says that she wants to go to a milk tea place downtown. Now her statement is very vague and you don't know exactly where she's talking about. Now your second friend is just as unhelpful as your first friend. He says, "Oh, do you mean the one next to the stoplight?" This is also very vague. Now judging from your two friends' statements, could you possibly come up with this answer? You answer with, "You must be talking about the milk tea place on the southwest corner of Lincoln Avenue and Carter Drive." Now there's absolutely no way you could have gotten this answer by listening to your friends' statements. Their statements were very vague, whereas your answer is very specific, which is the same concept of significant figures.
Created using Powtoon.
Too many numbers, not enough space.
Oh no. Well, look no further. With these simple tips and tricks, you can turn this long and huge number into this. My name is Tommy Doe, and with the help of my partner, Tommy Trinh, we will show you a trick called the significant figures that will help you get rid of those zeros.
Now, before we get into details of how this works, there are 3 crucial rules you must remember. Number 1, zeros at the beginning of numbers are never significant. Number 2, zeros at the end of numbers are not significant unless, which I will get into later. Number 3, zeros that are between two non-zeros are always significant. So let's say we have a number of this long number, right? Then we ask ourselves, how many significant figures are there, keeping in mind of the three general rules. So in this case, the significant numbers are 4, 1, 8, and 2, not these zeros. Because the zeros in front of them are not between any non-zero numbers, so only these four are the significant figures. The same goes for numbers like this. There are only 4 significant figures, excluding all these zeros right here. So the number would be only 4, 9, 4, 1. Now let's say there's a number, so let's say there's a number like 3, 2, 0, 1, 0, 0, 0, 0, 0. There, the significant numbers would still be 3, 2, 0, 1, including this 0 right here because it is between these two non-zero numbers. So unless these zeros are between, let's say, another non-zero like 1, then these would all count as significant figures. Now here are 6 problems I have created for you. Now can you tell me where and how many significant numbers there are? Keeping in mind of the 3 general rules. Now, let's see if you guys have done this correctly. So, for number 1, how many significant numbers are there? So, for number 1, there would be only 5 because these numbers are significant figures, excluding these zeros right here. So, these are out. For number 2, there will only be 1 because 5 is the only significant number there is. For number 3, there would only be 2 significant numbers because of 4 and 6, excluding these zeros. For number 4, there would be 4 significant numbers, including this 0 right here because of one of the 3 general rules saying as long as the 0 is between 2 non-zero numbers, in this case 4 and 6, it makes this 0 a significant number. For number 5, there would be 5 significant numbers, including these zeros right here, just as the number 4 we did previously. For number 6, there will only be 2 significant numbers, 1 and 2. Now, did you guys get the same correct answer as I did? So now you guys got the hang of that. Let's say we have a number like 0.00000007290. How many significant numbers will there be? Well, in this case, there will only be 4 significant numbers, including this zeros right here. Now, referring back to rule number 2, we said that zeros at the end of a number are not significant. Well, in this case, this is not true because there is a decimal in front of a non-zero number. So everything behind that would make it significant, including this 0 right here. So now I'm going to make more examples to show you. So how many significant figures will there be? For letter A, there will be only 5 significant figures, which are 3, 0, 2, 0, 0, including these zeros in the back. For letter B, there will be 5 significant figures, including the zeros in the back too, because of the decimal. And for letter C, there will be also 5 because it's the same as letter B. For letter D, as you see we did at letter A, it will be the same concept. So 3, 2, 0, 0. So there will be 4 significant numbers. Now I'm going to create 6 more problems for you to answer. Now, keep in mind of the 3 general rules, how many significant figures are in each of these problems. For number 1, there will be 6 significant numbers, 2, 0, 1, 0, 0, 0, because these are all behind number 2. For number 2, there will be 5 significant numbers, 2, 3, 0, 0, 1, including these 2 zeros because it's in between 2 non-zeros, 3 and 1. For number 3, there will only be 3 significant numbers, 3, 0, 0. For number 4, there will be 7 significant numbers, 2, 4, 0, 0, 0, 4, 1, because like number 2, these zeros right here are in between 2 non-zeros, 4 and 4. For number 5, there will be 7 significant numbers, 2, 4, 0, 0, 0, 1, 0, 0. Number 6 will only have 2 significant numbers, 2 and 1. So now that you guys got the hang of that, let's see how you guys can apply this skill to rounding numbers. So we have 4, 2, 0, 0, 8, 0, 0, 0, 1, 2, 5, 6, 2, 4, 2, 5, 2, 1, 7, 0, 1, 0, 0, 0, 1, 7, 8, 3, 7, 9, 0, 1, 1, 2, 0. So, our objective here is to round these numbers into 4 significant figures. So for this number right here, we want to get 4 significant figures, so we count 1, 2, 3, 4, and we round to the next number. So this number would turn out to be 4, 2, 0, 1, 0, 0, 0, 0, containing only 4 significant numbers. For this number right here, we do the same thing. So 1, 2, 3, 4. And what you would get would be 1, 2, 5, 6, 0, 0, 0, 0, 0, 0, 0. Now let's give you guys a chance to try. So for these numbers that I'm going to make for you, you're only going to find 3 significant numbers or figures. So for 1, 7, 3, 7, 9, 2, 2.00, 2, 5, 0, 2, 1, 3, 0, 0, 0, 0, 3, 1, 9, 2, 4 would be 30. So for these problems, you want to round so that the number will only come out to 3 significant figures. So now let's see if you guys have the same answers as I do. For number 1, you want 3 significant figures. So you count 1, 2, 3, and you round it to the 7. So your number would come out as 1, 7, 4, 0, 0, 0, with 3 significant figures. For number 2, since these are zeros, they're non-significant, you count 1, 2, 3. Your number would come out as 0.00250 with 3 significant figures. For number 3, it would be the same concept as number 2. So, excluding these zeros right here, count 1, 2, 3, and after you round it, it would come out as 0.000319 with 3 significant figures. For number 4, it would be the same as the example I showed you earlier, since there is no third number right here. You would make it 1, 2, decimal place, 0. So it will come out as 3, 0, 3, 0 with 3 significant figures. Alright, so now I'm going to make 4 more problems for you guys to answer. But this time, I want you guys to find 4 significant figures in the numbers I'm going to show you guys. for number 1, it would be 2, 4, 9, 4, 4, 1. For number 2, it would be 0, 0, 0, 2, 5, 0, 1, 2. Number 3 would be 1, 2, 0, 4, 9, 0, 0, 2. Number 4 would be 0 0.00 2, 0, 0, 2, 1, 0. Now, after rounding it, what would your significant figures be? Keeping in mind that you're only supposed to round it to 4 significant figures. So, let's see what you guys got. So for number 1, you would count 1, 2, 3, 4 significant figures and round it. So this would end up as 2, 4, 9, 4, 0, 0 with 4 significant figures. For number 2, exclude these zeros, count 1, 2, 3, 4, and then you round it. You would get 0.0025 0, 1, 0, 0. Or you don't have to put these zeros right here, and you would end up as 4 significant figures. For number 3, you would count 1, 2, 3, 4. You round it to the 9. Your number would end up as 1, 2, 0, 5, 0, 0, 0, 0 with 4 significant figures. This is the same thing as number 2, so you exclude these zeros. Count 1, 2, 3, 4. And remember from the general rule that these zeros are significant because it's in between two non-zeros, number 2 and 2. Then you round it to number 1. Your number would come as 0, 2, 0, 0, 2 with 4 significant figures. Now that you got the hang of sig figs and rounding with sig figs, let's try implementing them into multiplying and dividing numbers. Now before I get into details of how to solve these problems, I'm going to introduce 2 steps showing you how to round correctly when dealing multiplying and dividing numbers to significant figures. So the first step is to count the numbers of significant figures in each number. The second step is to round your answer to the least significant figures. So I'm going to show you an example of how to divide. So let's say we have 4,560 over 14. You would get 325, 4, 2, 8, 5, 7, 1, 4. And now you're going to count how many significant figures are there in these two numbers. So in the first one, there is 1, 2, 3. So 3 sig fig. The bottom one is 1, 2. 2 sig fig. Now, for step 2, you're going to round your answer to the least amount of significant figures. So the least amount we have here is 2. So you're going to go 1, 2, and you're going to round to number 5. Your final answer should only contain 2 significant figures. So your final answer would be 330. So now I'm going to show you how to multiply. So this is basically the same concept as dividing. So let's say you have a problem like 13.1 times 1.2039. Your answer would be 15.77109. And just like dividing, you would count how many significant figures are there in these two numbers. So here, 1, 2, 3. And here you have 1, 2, 3, 4, 5. 3 sig fig. 5 sig fig. And then for step 2, you count the least amount of significant figures. So in this case it would be 3. Your final answer should only contain 3 significant figures. So 1, 2, 3. You round it to this number. Your final answer should be 15.8 with only 3 significant figures. Now that I've showed you how to do it, I'm going to give you 6 problems and see if you can get the same answer as I do. So for number 1, now let's see if you guys can get the same answer as I do. Now for number 1, you can use a calculator to solve these problems too. So 1247 times 70. Your answer will come out as 36.9. And then first step, you count how many significant figures there are in each of these numbers. For this one, it will be 1, 2, 3, 4, 5. This one will be 1, 2. So 2, 5. Step 2, you count the least amount of significant figures to round your final answer. In this case it's 2. So 1, 2, and you round it to the 6. Your final answer should only contain 2 significant figures. For number 2, let's see, times 12, your answer will come out as 3720. First step, significant figures. So 1, 2, 3, 4, 1, 2. You use the least amount of significant figures, so then it will be 2, 1, 2, round it. Final answer should be 370 with 2 significant figures. Number 3, 125. You will get 1. Then you count significant figures. 1, 2, 3. 1, 2, 3, 4, 5. The least amount, your answer will come out as 181. For dividing, let's see. You would get 2, 28.91, 662. And you count significant figures, so it'll be 2, 1, 2, 3, 4. 4 least amount. 1, 2. Yes. Final answer should be 29.
After learning how to round, you may realize that it is necessary to round to a decimal place in some cases. Look at this number right here. The 2 is in the hundred thousandths place, the 4 is in the 10,000ths place, the 7 is in the thousandths place, the 5 is in the hundreds place, the 7 is in the tens place, the 8th is in the ones place, and the 1 is in the tenths place, the 3 is in the hundreds place, and the 6 is in the thousandths place. So if we round to a certain decimal place, then that could affect the amount of significant figures in the entire number. For example, if I round to the hundreds place, which is at the 5, there will be no significant figures to the right of the 5. It will be rounded to 247,500. Likewise, if we would be rounded to the thousands place, which is at the 7, then the number will be rounded to 207,000. Now that you know where the decimal places are, let's try some examples. So, write this number down. 3, 18, 2, 29.2. So, for these examples, we'll round to the tens place, which is right here. So for number 1, we know that the 1 is in the tens place, so you would look over to the ones place. If it's 5 Remember that zeros in a number are not always important or significant. With this in mind, it'll make a big difference in how we add or subtract. For example, let's say if there's a swimming pool that can hold 30,000 gallons of water. So if I fill the pool up to the maximum fill line and then add just one more gallon to the pool, would I then have exactly 30,001 gallon of water? No, because I would still have approximately 30,000 gallons before and after I added the extra gallon. Because 30,000 gallons is not a very precise measurement. In this case, we can see that why 30,000 plus 1 equals 30,000. However, rounding numbers when adding and subtracting is different from multiplying and dividing. For multiplying and dividing, we counted the number of significant figures in each number and rounded the answer to the least number of significant figures. However, for adding and subtracting, you would round to the least specific decimal place of any number in the problem. So for this example, we'll add. So I'll write 350.04 plus 720. So the least specific number or significant figure for 350.04 is 4, which is in the hundreds place. However, for the least specific number figure in the number 720 is in the So for this example, we'll be subtracting now. So we'll be subtracting 7,000 minus 1,770. So for 7,000, the least specific significant figure is in the thousands place. And for 1,770, the least specific is the 7 in the tens place. Out of the two, the 7 in the thousands place for 7,000 is the least specific. So, but when we first subtract them, it comes out to 5,230. Knowing that we have to round to the thousands place because it's the least specific out of the two, we would round to 5,000. Okay, now I want you guys to try. So I'll write down 6 problems for you guys to practice with. So 24.28 plus 12.5 and 120,000 plus 420. Then 3, 140,100 minus 1,422. Number 4, 2.24 minus 0.4101, and then 12,470 plus 2,200.44. Number 6, 450 minus 12.8. Alright. .28, the 8th is the least specific, and it is in the hundreds place, whereas 12.5, the 5 is in the least specific place, and it is in the tens place. Therefore, we would round to the tens place because the 5 is the least specific out of the two, so it will be 36.8. For 120,000 plus 420, it would come out to 120,000 and 420. For 120,000, the 2 is in the 10,000s place, and then the 2 and 420 is in the tens place. Therefore, we would round to the 10,000th place because the 2 is the least specific out of the 2, so it would be 120,000. For 140,000 and then 100 minus 1,422, it would come out to 108,678. So for 140,100, the 1 is the least specific and it is in the hundreds place, whereas 1,422 is in the ones place. So we would round to the hundreds place because this is the least specific out of the 2. So we would round it to 138,700. Okay, so when we subtract 2.24 minus 0.410, it would come out to 1.8299. So for 2.24, 4 is in the least specific place and it is in the hundreds place, and the 1 is in the hundreds place. So we round to the hundreds place for both of them, so it would be 1.83. So for number 5, we had 12,470 plus 2,200.44, which would come out to 14,670.44. So looking at 12,470, the 7 is the least specific and it is in the 10th place, whereas 2,200.44, the 4 is the least specific and it is in the hundreds place, so therefore we would round to the 10th place, so that would be 14,670. And last but not least, we had 450 minus 12.8, which would come out to 437.2. So 450, the 5 is the least specific and is in the 10th place, whereas 12.8, the 8 is in the 10th place. So we round to the 10th place instead of the 10th place, so it would come out to 440. So now you know everything there is to significant figures and how to round them, and hopefully you can apply this in your future applications.
Thank you very much for joining us.